This program tonight is made possible through the very generous support of Aerojet Rocketdyne and United Launch Alliance. We have some representatives here in the audience tonight. Please join me in thanking them for their wonderful support of this program. I'm very pleased to welcome Dr. Farouk El-Baz back to the museum tonight. He is, as we mentioned a few minutes ago, the founding director of the Center for Earth and Planetary Studies here at the museum, and my very first supervisor here. And that is many, many more years ago than I am going to admit to you. Farouk's first association with Apollo was at Belcom, a NASA contractor advising on lunar science and communications planning. While he was there, he became supervisor of lunar science planning and operations, and his many contributions to Apollo included serving as secretary of the Landing Site Selection Committee, principal investigator of visual observations and photography, and chairman of the astronaut training group of the Apollo photo team. When the Apollo program ended, Farouk came over here to the museum and established the Center for Earth and Planetary Studies, which remains today a thriving science research organization with over 10 scientists who study the terrestrial planets and the moons of the outer solar system, and who are on the science teams of many NASA programs, NASA missions, past and present. While he was at the center, he was also principal investigator for Earth observations and photography on the Apollo-Soyuz Test Project, the joint USSR mission, often called the handshake in space. And he also served as science advisor to President Anwar Sadat of Egypt. In 1986, he moved to Boston University and is recently retired from there as the founding director of their Center for Remote Sensing. So I look in the audience, I'm very pleased to see lots of young people here tonight. And for those of us who were around during the Apollo days, I can tell you it was an exciting time that was really unlike any other. I think it's a real privilege for us to be able to hear from those like our speaker tonight who were in the thick of it and eyewitness to how it all came to be. So please join me in welcoming Farouk El-Baz.
Thank you, Chris. Thanks. Thank you very much, Chris. I'm very proud of you and what you've done and what you're doing still. So stay there. Keep it up. It really is amazing what happened in the early 60s and the way it developed. And I would like to do this through a series of photographs to project them and then talk about them. If we have the first slide, please. As we go through the whole process of the Apollo missions to the moon and what did happen and what was my role in the whole thing. And one of the things that we'd like to emphasize is the fact that the interest of human beings in the moon goes back thousands of years, as we talked here about the fact that the ancient Egyptians had a goddess with Khinsu about the moon, and it was very important where the moon is and what the shape of the moon is, and all of this had been very significant to them. All the way throughout history, the moon had a position in the human mind. And the first time that we actually got some view of the moon, next, is the map that was first made by Galileo Galilei in Italy, where he trained the very first telescope to see the moon and actually saw all kinds of little things that varied. And in addition to the black areas on the moon, he saw some high ground, and he began to name the features of the moon. He called the flat black areas Maria, because they are like the seas. Like the Latin term mare is for sea. And then the bright areas he called terra, from meaning the land. So he imagined it to be like the Earth. So the flat areas, he called them seas, naturally, and the white areas, he called them the mountains, the terra, the mountain ranges. And then he picked up the mountain ranges, he called them the Alps and the Apennines and so on, after mountains of the Earth. So this was our first view of the features of the moon in 1610. The year 1610, when Galileo Galilei looked through his telescope to see these features of the moon. Next. And then 250 years later, Jules Verne thought about the trip to plan sending men to the moon. And it's fascinating that he thought that there will be 3 men going to the moon. And then the spacecraft would look like this. Lo and behold, it looks very much like the command module. 100 years later, we have something different from something new, but it certainly looked very much like that. Next, please. And there came NASA to divide a scheme, but sending missions to the moon with exactly the same 3 men within in a little capsule that looks like the command module. And actually, I took this picture to Rocco Petrone, which I will talk about in a minute, and he said, well, we must have all thought about that when we were young, and things like this stick to the mind, which is very true. The reason for the huge success for NASA, perhaps to this day, is this gentleman right here, and his name is James Webb, and Jim Webb was the first NASA administrator. He was there only for 6 or 7 years, and he is the one that kind of shaped the NASA theory and the NASA workforce and the NASA way of doing things. And I heard from Rocco Petrone, which I'll talk about in a minute, about how Jim Webb dealt with his people, and particularly the bosses of his people. Rocco said, when I became a supervisor, Jim Webb collected us all, and he said, listen, you guys, you became supervisors, which means that from now on, you don't do any work. And he said, well, we'll stop like this and say, what does he mean by this? He said, you don't do any work because your job from this day forward is to make sure that each and every man that works for you, there were no women, no men, no women in NASA at all, but you have to make sure that you can get every man that works for you to do more than what they think they are capable of doing. Only then we'll make it to the moon. Because if every man does what he thinks he's going to do, we'll fail. Surely fail, we'll never make it. But every man that works for you, if you can encourage them, push them, prod them to get to do more what they think they are capable of doing, then we'll make it to the moon. I think that statement can help any organization anywhere in the world. What is the supervisor's job? Next. Next was to make sure that happens. We were lucky to have this gentleman, Burton Brown, who was a rocket scientist who came from Germany, and thank God he joined the American troops after he escaped and joined the Americans when he knew that America is winning the war, Second World War. And he became the man that actually designed the spacecraft and looked all along, and he's the one behind the design of the Saturn V rocket, which allowed the mission to the moon to succeed as it did. Next, please. And the third pillar of NASA then was the Apollo program director, Rocco Petrone. Rocco was a very tough guy. An army engineer who got a master's degree at MIT, so he worked very hard, and he was certainly one man to know how to do things. He told me once, after we left the program after we both left NASA for 3 years was the fact that, Farouk, you know, when we were working on the Apollo missions and so on, 3 directors of 3 programs, of NASA programs before the Apollo program, came to me, see me in the office. And they said, how can you allow an Egyptian to be the secretary of landing site selection? This guy could be a plant from the Russians. The Soviets are all over Egypt. The Soviets could have sent him, they specifically, to mess up the Apollo program, especially landing site selection. If he selects the place where the astronauts would crash, then the program will be dead. So he may be a plant to do this. And he said, I told them, I did not put him in this job. It was his own fellow geologist that elected him the secretary of that committee. Don't tell me where he came from. Give me one thing that he did wrong, and I will throw him out the window with my own hands. He said, then they left. And then he said, I never told you that story so that would not affect your performance. See the beauty of the mind. And Rocco became a man that really had his finger on every little speck of the Apollo program. He would say the NASA Houston guys are claiming that there's something that they cannot do right, and there were going to be delays and whatnot. Farouk, you go down to Houston tomorrow and find out what is the problem with such and such. So I traveled to Houston and go down and between in the little offices, and they find out exactly what the story, and they go and find that John he has 6 people and this and that, but his boss doesn't want him to work on this thing, and he just can't do it, and therefore it will result in a delay or something. So I go back to Washington and tell him the story. So he said, okay, did you have his number? He said, Virginia, secretary was named Virginia. Virginia, come on, call this number. And then he calls this little engineer in Houston, and he said, hey, John, Farouk tells me that you're doing a great job. Listen, John, the whole Apollo program depends on your job. You're doing the one thing that you're going to do. I want you to get your people together and tell them that your job, the whole Apollo program stands on one foot until you find that you fix this job. Come on, do it, and if you need any help, call me. If you have any problem at night, here is my home number. And I'm sure the other guy, this John at the other end in Houston would be trembling with the Apollo program director is calling him from Washington. None of his bosses in Houston had ever talked to him. So he would go and do that job in 2 days and fix it instantly like this. So this was the style of management that's vastly different from anything I had never seen or I had never seen since. So these people were like that, and they knew how to encourage the workforce, and especially since the workforce was very young. Once we were down in the Apollo 11 time, I was talking with a bunch of astronauts, and we're looking at the people that are running the mission during the Apollo 11 mission. And we said, dear God in heaven, they look very young. And we said, okay, let's go and see the average age of these people. So we went down the whole corridors and asked them, how old are you? We'll write it down. Get the numbers and how old they were. And we found out that the median, the average age of the people that are running the Apollo missions during the mission, the critical most mission was 26 years old. And real. That depending on youth, and therefore, because you encourage them and you push them and you give them the responsibility, and they feel good and they say, my God, I will do this, that. Each one of them believes that he is running the whole damn mission. And they and keep them thinking this way and keep pushing them, and they do the wonders. Next, please. And therefore, we had 3 things to have done before the Apollo missions to the moon. First, there was a Ranger program, where they sent a spacecraft to hit the surface of the moon and to see how the impact of something like this would cause. Next. And this is what one of the things that we wanted to do actually was to get, as far as we're concerned, the geologists could get pictures of the approach of this little thing that is going to impact on the moon, so that we can see details of the features of the moon as the rocket approaches. Next. And the second program was called the Surveyor program, whereby we wanted to make absolutely certain that the spacecraft can actually land, because there were so many people, including some very loud scientists, that said that the moon, because of the continued bombardment by meteorites, the surface of the moon would be covered by a layer of dust. And the spacecraft, Apollo 11, is going to come like this and will go down and it will just disappear into that dust. And one of them, Tommy Gold, would be writing letters to the president, to the Senate, and everybody that would even read. And he had a position at the university, and he had a name, and so people were terrified in many ways, that they questioned our intellect about the fact that we thought that the moon was rocky and it will stand everything. So there was a necessity to actually prove that there is something that can be sent from the Earth to actually land on the moon and stay put, not disappear in the dust. And that was the Surveyor program. Next. So there were several missions to land on the surface of the moon and actually take pictures to show that, yes, indeed, the surface of the moon is hard enough to land, and there are rocks that can actually stand on the surface. Next. And the last item was the lunar orbiter. And the lunar orbiter program was the most significant of all of it, because it's just we sent something to go to the moon and rotate around the moon and take pictures and then relay them. And that relaying was done through Jet Propulsion Laboratory. And we have here with us tonight Tom Young. And Tom Young was at Langley Research Center, and he was responsible for getting us together to select sites for lunar orbiter missions. And the lunar orbiter brought us so many photographs that we could look at and interpret and figure out exactly what it is, and therefore we could figure where to land the Apollo missions one by one based on the photographs that. So the next, please. So the images of lunar orbiter allowed us to photograph as much of the near surface, the near side of the moon as much as we possibly can, with both the dark areas, which are the Mariad, the basalts, the volcanics, as well as the terra, the high ground. Next. So we began to think about what the features of the moon might be, and the missions as we go through them one by one. Next, please. Before the missions, there was a discussion, a great deal of discussion about what the surface of the moon might be, the craters of the moon, whether these craters were volcanic in origin or impact in origin. Volcanic meaning an eruption volcano, and then that's fused in and leaves the lava around it, and which would form all of these dark rocks that form the black areas on the surface of the moon, or the gray areas on the surface of the moon. And the other was, no, that were actually most of these craters are due to the impact of meteorites. And the interpretation of all of this and the selection of the landing sites would be based on all of these ideas. Where do we go? And the one man that was responsible for much of the geological mapping of the surface of the moon, and the idea of the fact that most of these large craters on the moon are due to the impact of meteorites, is Gene Shoemaker, who established a division within the U.S. Geological Survey that he called the Astrogeology Division. And it was based in Flagstaff, Arizona, near a meteorite impact crater. Next. Which showed us that if you have a crater on the Earth, and that crater is actually the result of a meteorite impact, then the stuff that's around the rim is going to be the roughest, and then farther away you go from the rim, the smaller the blocks, and that became a very interesting geological tool for us when we selected landing sites on the moon. So we would take the crater diameter and go 2 diameters away and say, if I am that far away from the rim, meaning that I am going to be away from all of the rubble that is due to that impact, knowing that most of these round craters craters are the result of meteorite impacts. Next. Next. Made it? Anyway, so we go then to look at the moon from orbit, and one of the most important things of the Apollo missions to the moon were, okay, the astronauts that will remain in orbit around the moon are going to take all kinds of photographs. And as I said earlier, this next, the very first picture of the Earth that we see of the moon from Apollo 8 was something that we never expected. You know, the astronauts never expected themselves, because they saw this view and they say, "Oh my God, do you see that?" And they ran out to get the camera to take a photograph of it. And that one picture became maybe the title page of the Apollo program, because it showed us, number one, that the Earth is a planet. The Earth is a beautiful planet, and it is one little thing. And as the astronaut said, we don't see any boundaries. We don't see the borders between countries. We don't see such and such, and it's all the same place, and it has an atmosphere that runs everywhere. And so it became kind of the call for the environmental movement. Began in 1960. In December 1968, as this picture came in, and then they spoke elegantly and quoted paragraphs or statements from the Bible, and this just became a significant view of the Earth as seen from the moon. Next, please. In the meantime, we had, I don't know what that is. That's another talk, man. So as they rotated around the moon, they began to look at the surface features, and then we wanted to certainly take as many photographs of the surface in detail, so that we can use these photographs for the selection of landing sites as much as we can possibly apply, knowing that we think about the rockiness of the surface and getting away from rough territory. Next. And so the things that we realized was the fact that, yes, indeed, that to have the view from the lunar or from the command module would allow us to have enough photographs to select the landing sites properly. And we did for Apollo 11, and then we got the shock of our lives, because during the Apollo 11 mission, we selected a 7-kilometer area where we know for sure that there is absolutely flat areas in there that they can land in, and we took the best one to them and in the center, and the spacecraft was supposed to be directed towards that one. And they came down as prescribed, and lo and behold, it was not going. The spacecraft was not going where they thought it was going to. And it was going to land over a small crater with lots of blocks in it, and these blocks were big as desk-sized blocks. And Neil Armstrong had to maneuver by hand and take the spacecraft and put it away from that thing. And we realized that what happened, only afterwards we realized that as the command module was separating from the command, as it was releasing the lander was there was an increased velocity, and the command module did not. We thought that the landing site would be here, but as the lander came in, it came further down by 7 kilometers and was going to land in the middle of a crater. So it missed the site that we had selected by a few kilometers, and therefore Neil Armstrong had to, by hand, manually move it away from that rockiness to save the mission. Next. Okay, and now they started going to walk on the moon. And one of the first things that we asked them to do is to take a picture of the footprint, because we wanted to know the thickness of the regolith, the very fine-grained layer, how much we know how much he weighs and how much he would sink in this layer. And because we knew that this kind of thing will remain there, so that we measure the shadow, and we know exactly the depth of this thing, and which means how what's the grain size of all of the dust material on the surface of the moon. Next. and then became the training of the astronauts and looking at the moon from orbit, in addition to the fact that the astronauts on the surface would describe the surface of the moon as they walk in, and they take samples and they describe the setting of the samples and so on. We wanted to have some more discussion of what is it that you can see from orbit, because the orbital observation help in selecting landing sites after that mission. And here we're talking to Stu Rusa, who was the command module pilot of Apollo mission 14. And so this, after the Apollo 13 mission, this became a very important, significant thing to land correctly and do it right. And then so that because we had several missions we were supposed to have up till Apollo 20. It not ended with 17. We had up till Apollo 20 missions to go to the moon. And so observations from lunar orbit were very significant to do so. And next, please. And we would take the Apollo program, the Apollo photographs taken from previous missions and show the new guys what all of these things. And in addition to the fact that some of the information is coming in from looking at describing the surface material and as well as the rocks and so on, that we have additional material, additional knowledge from the orbital observations. Next. And came this Apollo 15 mission, Al Worden, and Al Worden was a great observer. He really wanted to do it right, and he wanted to absorb as much as possibly can, and he became one of the best observers of all kinds of features. And while he was on Apollo 15 mission, he looked at the ground in a place that I asked him to look at, and he described it very nicely, and he said that there are actually volcanic eruptions in there, darker rock material, so this is an additional younger volcanics because they're darker looking and so on, and made a big deal out of it. And even Rocco Petrone, who was the Apollo program director, from a distance he pointed and came down to say, your student may have picked up a landing site for you. So he knew exactly what these statements may mean, that Al Worden describing younger volcanics and cinder cones very much like the ones that we saw near Flagstaff, Arizona, this kind of thing, that he said maybe that will be a push for one of the later missions, and indeed it was the site for Apollo mission 17. Next. And so the Apollo command module observations were very important, because in addition to the fact that we had also cameras, in that one metric camera to take real good topographic maps of the moon, and one panoramic camera which took very high resolution pictures so that we can see details down to a few meters of the surface of the moon. Next. Apollo 16 came, and this was the one place on the moon that we selected that was not exactly what we thought it would be. We selected a place near the central part of the moon whereby there are all kinds of hills like this, and Don Williams and I thought of them as hills that were actually built up by volcanic action in the highlands, and so we called them the Faro Terra, and the NASA headquarters loved it. Rocco Petrone loved this statement of Faro Terra. So what makes the Faroes, and what is Terra, and all of that. And we started sending it as the pile-up material, and not very different from the volcanics of the basalts. This will be such and such. And here comes the Apollo 16 crew with this, and they go up there and look at it and begin to say, well, this is all breccia. We're looking at ejecta from some impact crater. It's this and that, completely very different from what we thought. And so the site that we had selected to see is very different from all the Terra materials, was exactly like what we got from Apollo 11, from Apollo 13, and Apollo 14, and what we got from Apollo 15. Yeah. So Apollo 16 was our mess. So that's what, as far as site selection was concerned, that was the one that we didn't do it right. Next. The Apollo 17 mission was proved that the rover that we had taken was very useful, even though it was used for Apollo 15 and 16, but Apollo 17 was exceedingly useful to allow the astronauts to go to sample a mountain range and then go to sample a different crater in the south and then go east and have another look at a completely different crater. So it was the use of the rover was wonderful because it allowed the astronauts to drive away from the landing spot for 7 kilometers. And the 7 kilometers was actually not a limitation of the rover. It was a limitation of the oxygen tank that they carried, because they said if one oxygen tank goes kaput, say let's buy a micrometeorite or something, breaks it, or something little meteorite hits it and zaps it and it breaks, then they can actually, the two astronauts can actually breathe oxygen from the one tank, but that will take them for up to 7 kilometers of walking, and that's it. And therefore we said that the Jeep could not take them further than 7 kilometers from the spot. So there were limitations also that were placed on the human aspect, or the human needs up there on the moon. Next, please. And so the Apollo 17 mission, we were able to train them with images taken by Apollo 15, because we had very fabulous cameras, the metric camera and the panoramic camera, and we had magnificent images that they could actually see for Apollo 17, because the Apollo 17 track was close to the Apollo 15 track. So on Apollo 15 we had taken all of these magnificent pictures, so the Apollo 17 crew could use them. And here is we're talking to show these images from on the machine during the training program. Next. And the Apollo 15 mission, because of the availability of the rover to take them as far as regions away from them, they could collect a rock. Here you can see a geologist, Jack Schmidt, picking up a piece of this huge block that fell from high up on the mountain, and we knew that a piece of rock that is very high on the mountain would be different from the compositionally from the rock on the surface of the moon, and indeed it was. So that allowed us to get as much variety of the lunar surface materials as possible. Next. The tracks of the rover will be there forever. Because there is no wind, there is no rain, so these tracks will be there on the moon forever. So we'll know what mess up that we did from the moon will be recorded forever. Next. The rocks were, but the samples showed that the rock materials of the moon were very much like those of the Earth. There are some differences chemically. There are some concentrations of elements that are precious elements, maybe. There are some higher concentrations of thorium, of lithium, and some elements that are not on Earth, or very different from the concentrations on Earth. But basically, the rocks are very much like the Earth's material, formed in very close to the way they formed on the Earth. So the geological processes that we are familiar with on Earth would most likely function on all the planetary bodies, with differences in their environmental conditions or something or other, because of the size, because of the distance from the sun, because of the original composition. But whatever we learned on the Earth in geology, we can certainly apply towards all of the planetary bodies. Next. And we learn naturally that from the crystals that we see from the microscope. It's because we see exactly the same kind of patterns of rocks on Earth. Next. Then we came here to the Smithsonian Institution to establish the Air and Space Museum, and one of the first things that we did was to think about Apollo. And my good contribution, in addition to all of the kinds of things that we talked about, the scientific material and so on, and what did we do, and I wrote the script for the little movie called The Man in the Moon Remembers, whereby we wanted to show, because we didn't have much space to talk about the science because of the rockets and so on, the part of this Saturn V and all of the other the most important things that took the astronauts to the moon were there to, they just took most of the space. So the little movie of the Man in the Moon Remembers was to just summarize the history of the moon by saying that for about 4 billion years ago, the Earth and the moon were roaming around, and they formed from some material that emanated from the sun, most likely. And then the moon hardened, but as it hardened, there were little pieces that hit it, and each one that hit it would form this round thing, which is a crater, and the big craters like that form the face on the face of the man in the moon, and then all kinds of variations happened later and so on. But the thing that I'm very proud of is the fact that we were able to get a piece of the moon that people could touch. And I actually wanted to see that because of the fact that in my culture, there is something called the, in Mecca, whereby there is a meteorite that was a sign from God that people could touch when they go for the pilgrimage. And that affects the human beings of the Islamic faith tremendously. And I thought that maybe the little, if you have a piece of the moon that young kids could touch, it can affect them. It can say, I can reach the moon. I've touched the moon. I can get there. And so it can be something like that. So I thought we'll go get some at least. And we discussed it. And Mike Collins, who was my boss at the time, he said, well, you're the geologist. You go get them piece of the moon from Houston. So I go to our group, our the fellow geologists that were responsible for the division of the lunar material for scientists to study. And they would say, are you out of your mind? But what do you mean people touch it? And go and forth. Anyway, it took me 18 months to go back and forth and discuss with them and tell them. And they also thought, well, you have a piece of the moon on anyone, somebody is going to come and break it and take it, and we want to sell it for $1 billion, and what the hell do we do after? And somebody will come back and tell me, get us another box and another piece. I told them the piece of the meteorite that's in Arabia that people touch, 7 million people touch it every year, that's still there. And there is it's protected by just one fierce-looking Bedouin with a sword standing next to it. And John Adams, who was a good friend of mine, was a geologist from the University of Washington. He said, Farouk, if you get us a fierce-looking Bedouin with a sword, we'll give you a piece. Anyway, we finally got one, and we have it to touch the moon. And I was actually, after the museum opened, one of the most significant things that would happen to me is when I see young kids coming to look at it and to actually touch it, and a boy and his brother come and touch it, or once an old woman that had difficulty walking. To walk, and she said, oh my God, I have been waiting this all my life. So some things of this like made the whole effort of going to get that one piece of the moon for people to shut. Next. So there are all kinds of little things that happen like this that make a huge difference, and so that several missions afterwards showed us the features of the back of the moon. The far side of the moon, the details of it, and you can see there are no features of man in the moon. It is all of this white rock. There are very little of the dark volcanic or mare basalt. Next. And then there are all kinds of things now for the Japanese mission going to this southern region of the moon, because we know that there may be ice, water ice, in the southern polar region of the moon, because of the fact that it is in shadow all the time. So if there is some water, it can be frozen as ice, and it can remain right there in this area. Next, please. And the latest mission is actually next after that. The last mission now is the Chinese mission, whereby there is the Chinese landed a spacecraft, and they have a little rover. They actually move away from the spacecraft to investigate part of the far side of the moon. So this will allow us to consider what the chemistry of the far side might be, as opposed to the chemistry of the near side, if there are differences in the chemistry between the two, just because of the lock of the Earth. So there are all kinds of things that of the moon that were still talked about. There are people that think today about the potential of a mission to the moon to stay, and potential for some resource acquisition from the lunar materials, as well as the fact that it might be the first step towards going to Mars. So the moon will be right next to us for a very long period of time. And the chief scientist for NASA is with us today, and we'll tell him that's good luck, because we need to continue to look at the moon as far as its composition, its relationship to the Earth, and what we can learn from it for possible missions to Mars. Thank you very much.
Okay, we have some time for questions. Since the 18 through 20 were canceled, is there a site that you wish you could have gone to that you weren't able to go to?
Actually, yes, and there would be in the far side, and then like a crater called Tsiolkovsky, whereby there is a very big central peak, so that we'll see what the composition of the rest of the crust of the moon was like. So that's the important thing, to see what's on the backside. Yes, there are several, actually. On Mars, there are several questions on Mars. The surface material itself, the things that the sandy regions, the terrain where you have the channels, and the terrain where you have the volcanic built-up. So all of these, there are at least 3 completely different types of things where you could send people to get material, or get material from there, so that we can at least look at all the 3 different, the 3 general, very different materials.
How far along were things going before President Kennedy made his challenge?
How far along were things when President Kennedy made his challenge? How significant was that in moving things along?
Yeah, I was actually here at the time when he did that as a student. So I was not really very knowledgeable about what was going to be with NASA. But as far as the NASA people themselves are concerned, there will be absolutely no way that we'll be able to do that.
Do we have a question from the overflow in the planetarium? Okay, in the theater?
What are your thoughts on robotic versus human exploration?
What are your thoughts on robotic versus human exploration?
As far as I'm concerned, vastly different. The robotics are kind of bring you the information that's dry, and maybe you can interpret some of that information correctly, but the human aspect adds a great deal about the difference in color, the difference in the way it is, and all of these kinds of things are there. And without human beings, the Apollo legacy would not have been the same at all, because we had 3 different programs. I told him about it: Lunar Orbiter, Surveyor, Ranger. Nobody knows about him at all. Yeah, nobody gives a damn about it. Okay, they send the machine to over there and have a look at something and came back. Fine, that's it. Okay, next. But with the astronauts, human beings going in there and talking about it and endangering themselves, and well, all of this is another story altogether. That's fine. I mean, oh,
I'm going to just repeat the question. In Apollo 16, you identified a crater on the far side of the moon that you proposed to name after Necho. And the IAU put the name on a smaller crater. Did you have any thoughts on that?
well, the smaller crater was there, so the site was fine, and it didn't really matter at all. All the idea was recognizing this crater and recognizing that person. And that person was recognized only, in my view, because of the fact that he was, yes, he was a king of Egypt, but he was an individual himself. So thought that his land is surrounded by water on all sides. So he sent a general with a crew in a ship, and he said, you go from this sea and come back from the other one. So it actually it took him 3 years to go all around Africa and stopping to get food and water and this and that, because they didn't know where they were and what is it that this land is. Go all the way in Africa, and they actually drew the map of Africa in ancient Egyptian time. And this was, I was flabbergasted by that story myself. I thought this man requires a salute. So put him on the moon.
Were the surveyor programs classified at the time?
None of the NASA programs were classified. And that was a very important thing, that the NASA could not work on classified things, and therefore we were free to talk about any of this material.
Yeah, I'm curious if you have any thoughts as far as how Apollo could have, engaged the public more, so that maybe the budget wouldn't have been cut. Like maybe have the astronauts actually talk to people, talk to journalists while they're on the moon. Maybe you get a few less rocks, but the people are more engaged. Because people seem to be bored by time of 16 and 17.
Did you have any thoughts on how the Apollo program could have promoted itself to the public better, so that the later missions might not have been canceled if public interest was higher?
It was actually very difficult to get the Apollo astronauts to talk at all, whether to each other or to people. So it's none of them were really public relations astute. Yeah, so that none of them had the facility to do this beautifully. I mean, the only one that proved to be good in later time was Apollo 13's crew. Jim Lovell, meaning.
I'll just check. Are there any questions from the planetarium overflow? Okay.
Discovered some caves on the moon. Is there any plan of using them?
The Lunar Reconnaissance Orbiter mission has observed some very deep cave-like structures on the moon. Do you know of any uses for those or plans for those?
Not at all, because this is perfectly okay to happen in a rock that was formed by lava flow and then dried up, because there could be cavities formed by collapse or by the lava moving away, and there would be a very thin top layer, and it would fall. So there is no reason to believe that they are otherwise made by something else.
I heard they were very big.
Yeah.
The Japanese did some research on them.
Yeah, and there are the channels on the surface of the moon that are several hundred kilometers long, or several hundred miles long, or also deep.
You said before that the gravitational pull affected the geology of the moon that's near us. What side of the moon would be safest, knowing what we know about the backside of the moon now, to land for a future moon?
Given the differences between the near side and the far side, which area would be safer for landing?
Safety is in both ways, because the only problem on the surface of the moon today is what the potential for a meteorite impact that happen if you want to stay there for a long time or period of time or something, or because the safety of landing Apollo 15 or Apollo 16 in any other similar place on the backside of the moon will be perfectly okay. Same. There is no difference in the safety issue.
So both the samples that were brought back from all the Apollo missions and analyzed, what are the biggest surprises once you got to
That they were really the rocks of the moon, yeah, sorry.
What were big surprises that you found in the Apollo samples?
There were no real surprises. Most of the material was either very much like those of the Earth, or if there is any difference, it's because of the difference in the size of the both.
Technology in laboratories has advanced greatly since the Apollo years. What are we finding out new when we go back and look at the Apollo rocks now?
What are we finding new now that we go back and look at the rocks with newer technologies?
We're just about to start this now, because one of the things that we emphasized very strongly just about before the Apollo mission started was the fact that we need to save at least half of the lunar materials completely untouched and lock it up with the gold in Fort Knox or whatever, to make sure that, because someday somebody is going to generate a very clever method of looking at rocks and finding out all kinds of things that we don't know at the time of them. And we said for at least 50 years. And this year, NASA began to think about, okay, how much can we release of the locked up material that nobody has touched? So just beginning now to see what might be different.
The question I've got is, you're at the Lunar Receiving Laboratory. There is the samples for Apollo 11. Your first thoughts?
What were your first thoughts upon receipt of the first Apollo samples?
That indeed it is basalt. It is very much like the basalts that we see on Earth. It has more pits on it from the hitting of the micrometeorites, of zapping them. But it is very much like that, and lo and behold, geology wins. It is what we thought it might be.
Was there any like, holy cow, this is the moon? That kind of emotion.
No, the holy cow was before the thing, but by the rocket that actually went to the moon, more than the rock that we see, because the rock we seen, we expected that.
One last question.
Here.
Yeah,
Oh, yes.
Farouk, and I'll address you as Farouk because we know each other. I was part of the Belcom team from the beginning, and if you have a moment to just say hi after you retrieve the questions, I appreciate that.
A friend of Farouk's from the Belcom days is here.
Still kicking.
One last question.
When Apollo 17, Harrison Jack Schmidt was the one scientist, actually geologist, to actually walk with him. Did you have some, special discussions with him prior, to the mission in terms of things that, to look for and things to do?
Oh, very much so. And, oops, sorry.
Did you have any special discussions with Jack Schmidt on Apollo 17, since he was the only trained schooled geologist to go to the moon?
We had discussions for 3 years, because we're thinking about where he would be and what we needed a geologist to go and what would geologists do, and we wanted to make absolutely certain that he in himself kind of made sure that his language was clear enough, not totally geological, so that will be just like the other guys, but give us a hint of what he means about it and so on. Yes, indeed. Because he's a geologist, we expected a lot more from him. First of all, because he's a geologist, we really wanted him to fly. And it was sad to see the one very good guy that removed to put Jack Schmidt in there, but we certainly wanted something like that. And the NASA had to do that because they have a scientist, a geologist, to fly to the moon, and they have one, so he was qualified. They had to do it, and we also then had to see that he was good enough to prove to the world that that was a good thing to do. In the meantime, he made an observation that turned out to be totally wrong. But that happens to geologists.
Well, thank you very much, Farouk, for a wonderful lecture tonight. I'd like to thank once again our sponsors, Aerojet Rocketdyne and United Launch Alliance, for supporting this great program this evening. Unfortunately, I guess it's too cloudy. The public observatory will not be open for viewing tonight. And please don't forget to join us next month on April 24th for the next lecture in the series, where we'll get an update on lunar science.
Thank you, Pris, for all you're doing.